All right, everyone. So in this video, we are going to be talking about aldehydes, about the aldehydes and ketones. And basically, guys, we have talked about these before when we were learning how to identify functional groups. So first thing first, we want to be able to distinguish aldehyde and ketone. So we have that out of the way. Okay, so first of all, the aldehydes, basically, both aldehydes and ketones have something in common. That's why they're look confusing. Is They both have the C double bond O, guys. Now, one of them, what actually happens is one has the hydrogen where the C double bond O is. Okay, so first of all, the C double bond O, guys, this itself is called carbonyl. So if your carbon, so the carbonyl carbon is attached to carbon on one side. So guys, what does R mean? R just means alkyl group, and alkyl group basically just means that you have a carbon chain here. It could be one carbon, two carbon, 10 carbons, it doesn't matter. So just a general notation for carbons is we put a R. We don't identify how many. We don't want to be specific that just one carbon will be aldehyde, others won't. The idea is that you have any number of carbons that will be an aldehyde. So that's why a generic symbol R is used to show a number of carbons. Okay. Now, so carbonyl, it's attached to a carbon on one side and it's attached to hydrogen on the other side. This is when you have aldehydes. Okay. So let me erase the word carbonyl. So carbonyl is just C double bond O. C double bond O is also present in ketones. So aldehyde and ketones both have carbonyl in them. But this right here that you see, this guy here is aldehyde. Okay. So then you would ask, how are ketones different? So guys, the ketones, what happens with ketones is you have, again, carbons, R meaning you have any numbers of carbons. Again, we got the carbonyl. Now on this side, you got more carbons. So we can show that with R, showing that, okay, this side carbons are same as this side carbon, or to distinguish that this side could be different from this side, we use R prime. Okay, so again, R here just means we got carbons. Okay, now if we look at again carefully, the carbonyl is sandwiched between two carbons. Guys, this is when you have a ketone body. Okay, so when you have a ketone functional group, basically, and by the way, that's where the term ketogenic diet comes from. So the keto diet basically is our body uses fat, and in that metabolism, when your body is breaking down fat, it makes a lot of ketone bodies, and that's why those diets are called keto diets. They're very low carb, almost no carb diet. Only you only eat fat and protein. Okay. All right. Later on, we'll talk a little more about these later on when we in later weeks when we study carbohydrates, lipids, and proteins. Okay. All right. So again, the idea here is to understand the difference between aldehyde and ketone. So make sure you understand this. Aldehydes, they are carbonyl, but at the very end of the molecule, that's why you see the hydrogen. There are no more carbons here. Whereas in ketone, you have carbons on the left and carbons on the right. So that's the difference. Now we need to learn how to name them. Just like other nomenclature, we should be able to name the aldehydes and ketones. So we'll start with aldehydes first. We'll learn what suffix do we use for aldehydes. So guys, let's take a simple example. So if I give you, let's say, um, so this is how many carbons? This is one carbon, two, three, and this is a fourth carbon. And let's put the double bond O here. And again, just to show that what do we have here? We actually have hydrogen on this side. So if you just make a line and don't show hydrogen, that would mean that you're trying to say there's a carbon here. So we need to explicitly tell that this here is a hydrogen. If you just make a line and leave it, that would mean you have a carbon, which we don't, okay, in case of aldehyde. Okay, so now what do we have? This point, guys, this is the carbon, where you have this, where you have the double bond O. So this is the carbonyl carbon. So this, first of all, will always count as one. So guys, the cool thing about aldehydes is because they're always at the end, or you can say they're always at the beginning, you can say. So they always get the number one. So there's no need for aldehydes for you to give them one. Okay, we'll see later on when we should, just in a couple of cases, but in general, when you're working with aldehydes, we actually don't need to put one for the aldehydes. But we understand that since we have, just to count how many carbons we have one, two, three, and four carbons. So guys, if you have four carbons, what do we call that? So our base name, if we have four carbons, is butane. So what do we have here? We have a butane. And again, I would put an E if this was just butane, but it's not. It's not just butane. It's an aldehyde. So guys, for aldehyde, the suffix we use is actually Al. Okay, so remember that from the aldehyde. I mean, alcohols also have Al in the beginning, but we don't put Al for alcohols. We instead put Ol. Like if we had an alcohol with four carbons, we would be calling it butanol. But now when we have aldehydes, we're instead going to be calling this butanol, okay, with an Al at the end, okay? Now, again, just like I mentioned before, there's no need for us to say that it's butane 1-O or it's 1-butanol, because it's obvious that if you have an aldehyde, it must be the C double bond O sitting at the very beginning, or again, as we were saying earlier, at the very end with the hydrogen. There are no more carbons on this side, so it'll always be at one end, okay? All right, so that's butanol. Okay, now just so that we can compare it to, so what happens if we have more longer carbon chains and we have more substituents, then what do we do with them? So let's take an example where we have this. Now again, this is C double bond O and this is hydrogen. If I don't put hydrogen, again, remember that would mean that we have a carbon that actually will become a ketone, not an aldehyde. Okay, and then imagine there is a substituent sitting here, okay? We got a one carbon substituent. So this naming will be just like the other namings we have been doing so far. Again, the numbering always needs to start from the aldehyde. So you will notice when we learn more of the functional groups, you'll notice that the functional groups that are always at the ends, like aldehyde is always at one end. We'll learn later carboxylic acid will be at one end. In those cases, most of the times, that's where the numbering will start from, okay? All right. Okay, so now here we got CH3. So when you don't say anything, that means there's a carbon here. And when you just have one carbon, guys, what is that called? That is called metal. So our substituent here is metal, okay? Okay, so now just like we name other organic molecules, what we need to do here is we count the number of carbons. We got 7 carbons. What is the root name for 7 carbons? So we use the term heptane. Okay, so hept is for 7, ane is telling us that they're all single bonds, so heptane is good. Now what do we put for aldehydes? We know that we're going to be putting Al for aldehyde. Guys, do we need to put 1L, or do we have to say 1-heptanol? No, we don't, because aldehydes we know by we know by default that they're going to be at one end, okay, and that's where the numbering must begin. Okay, now again with some exceptions which we'll learn later. When the aldehyde will not be the highest priority. Okay, we will learn that later. Okay, so for now, since we want to put the first name here, this was the last name. The first name is metal, so we need to put metal here. And for metal, we of course need to tell what position it's on. It's sitting on carbon number 6, so we'll just say 6-methyl heptanol. Okay, all right. Let's learn a little bit about the ketones as well. Okay, all right. Okay, so now when it comes to ketones, remember the key here is that the ketones will have the carbonyl group sandwiched between carbons. So there will be carbons, C double bond O, and then there'll be more carbons, okay? It does not matter how many carbons you have here or how many carbons you have on this side, okay? So that's what tells you have a ketone, okay? So now for a ketone, what is the suffix that we use? Just that for aldehydes, we use Al. What do we use for ketone? So let's take the simplest ketone, guys. So for ketone, the smallest ketone that can ever be made must have 3 carbons, right? Because if I have a carbonyl at the center, you need at least 1 carbon in each side to call it a ketone. So guys, the simplest ketone has 3 carbons. And guys, when you have 3 carbons, you use the word prop, right? Because again, Butane is 4 carbons, propane is 3 carbons, ethane is 2, methane is 1. So when I have three carbons, so I use the term prop. Prop is telling us that you have 4 carbons. Propane will tell us, the ane is going to tell us they're all single bonds, which they are. And then what suffix do we use for ketones? So for ketones, the suffix used is -one, just like the ketone has the term O-N-E. So ketone ends with -one. Your names for ketone should also end with -one. So propanone. Of course, it's spelled as O-N-E as in one, but we call it -one. So propanone. Okay. Now, this molecule right here, guys, it's a very, very common molecule. Its common name is acetone. And it's so common that you should actually know that name and you should know that the propanone is called acetone, okay? All right. So when it comes to the ketones, let's do some more examples, okay? So let's say we have a ketone. Since it's a ketone, you must have carbonyl setting surrounded by carbons, okay? So how do we name this one? For this one, of course, the name is going to start from where the double bond O is going to get the smaller number. So this is going to be 1, this is going to be 2, 3, 4, 5, 6, and 7. So again, guys, we know that the last name should have 7 carbons, so this should be heptane. So far you say heptane, and then for the ketone we used ONE at the end, so heptanone. Again, remember, don't put the E in between because we don't want two vowels that are next to each other. So you want to end the names with the vowel, and that's why you're putting the E at the end. Or earlier when we just learning heptane, we added the E at the end. But the ane is the actual thing that tells you that you have a single bond, not that E in the back. So you have to drop that E. So don't write that E. We actually put that E, you're putting that E at the end of the own, right? It's already there, okay? Okay, so heptanone. Now, since this double bond O could have been sitting on 3rd or 4th carbon, we need to tell that where that ketone double bond O is. That was not the case with the aldehydes, because aldehydes were always at the end. But for ketones, we do need to tell where the double bond is. So in this case, it's sitting on carbon number 2. So we say 2-heptanone. You could have also called it heptane 2-one, and that's also totally fine. Okay. All right. So now what if we put a new substituent on this? What if we had a bromine sitting here? It will be very simple. You just add 5-bromo in the beginning, and that is it. 5-bromo heptane 2-one. So it's that simple.